When working with derivatives, there are some rules or shortcuts that you can apply to make your life easier.
One of the most basic rules is that if f of x is a constant, then the derivative for f of x is 0. For example, if f of x is always 3, then the derivative of f of x is 0. This makes sense if you think about it. The derivative is the measure of a slope of a function, and that's caused by different values being returned for different x values. If the same value is always returned for different x values, then the slope remains flat, so the derivative is 0. Another really useful rule is known as the power rule, and it states that when f of x is x to some power, then the derivative of f of x is the exponential times x to the same power minus 1. So for example, if f of x is x to the power of 3, then the derivative of f of x is 3x to the power of 2. Here's the graph of f and its derivative. F of x is shown in blue and the derivative is shown in orange. Now note that as we move from negative values of x, the slope is reducing from a fairly steep upward tangent towards an almost flat tangent at 0. Now this is reflected in the fact that the derivative line shows a gradual reduction in slope towards 0. Then the function line changes direction and starts to increase its slope. And that's reflected in the increase in the derivative line. Now there are some other useful rules for working with functions and their derivatives. For example, if a function is defined as the sum of two other functions, then its derivative is the sum of the derivatives for those functions. If function f is defined as the product of functions g and h multiplied together, then the derivative of f can be calculated by adding together the results of multiplying the derivative of g by h and the derivative of h by g. This is known as the product rule. Similarly, the quotient rule gives a formula to calculate the derivative of a function that's defined by the division of two other functions. And finally, the chain rule is useful when a function can be represented as one function nested within another. You'll learn more about these rules in the lab for this section.